calculating surface area. Essentially what I want to do is to give you as many as many practice shots at it as we possibly can. I'm looking for a piece of paper that I had and now I've lost. So if you think I'm normally all over the place, I'm probably going to be more today. So anyway, there's the function. We're going to do it. I have no idea where we're going to do it. We're going to do it from what to what? From something to 2 pi. Okay. From x equals 0 to, say, 4 pi. Yeah, that'll do. And it's rotation about the x-axis. Well, since everything is in x's and we're rotating about the x-axis, it's this formula here. I'm going to do the derivative. If you differentiate a cosine, you get a sine. Actually, you get a negative sign. And don't you also get times a quarter because of the 1/4 x? If you then 1 add this guy squared, you get 1 plus this guy squared. You've got some terms all being squared, so I can square them individually. Negative 1/4 gets you 1/16. Sine squared 1/4 x. So that's kind of where we are. In this particular question, there's really not any useful trig identity that I can use to turn this into anything. So I'm going to go straight into the formula and see if we can get out of this that way. So it's going to be the integral from 0 to 4 pi. 2 pi f of x times the square root of that guy. Okay, no way out of this one. This is an ugly u sub. And it's not even a nice u sub in the sense that the u sub is everything inside the square root. If you tried everything inside the square root, it didn't work, right? You get bits left over you can't get rid of. But it is nonetheless a u sub. So I want you to try and think of another u sub that would work.
Sine 1/4 x.
I like that. I'm just going to add an extra quarter. It could work with sine 1/4 x, but you would have an extra couple of lines at the end that you'd have to do to fix something. So if I do this, I don't need that. If you differentiate with respect to x, you would get a cosine of 1/4 x times another quarter, which is why that is 1/16. If you do the crossover, you get that. And if you divide everything by this, you get 16 over the cosine of 1/4 x du dx. Are you okay with that? Are you happy about the 16 where it ends up? Okay, now we can kind of switch pages, go over here. So it's going to be the integral from 0 to 4 pi, 2 pi cosine of 1/4 x times the square root of 1 plus, since I am using a u sub of 1/4 sine x, this fellow here becomes u squared. and the dx becomes 16 for the cosine 1/4 x dx. Are you happy about 1 plus 1/16 sine squared is 1 plus u squared?
You did u equals 1/4. What about
Right.
the 1/16?
Ah, well, here we go. If u is 1/4 sine a quarter x, then u squared will be this guy times himself. And 1/4 times another 1/4, that gets you the 16th. And sine times itself gets you the sine squared. So that is why u squared is that guy.
Okay.
Now, a little bit cancelling out. Cancel, cancel. 6 and 2 gets me, I believe, 12 pi. And now we're looking at one of these guys. And when you get to a situation like this where it's not, you know that there's more work to do, there is a shortcut, which I have now set up, and we'll show you how to do it. That integral there is a standard integral. That's just another name for an integral that crops up a lot of times in math, and it crops up so that it's helpful if you can just look at someone else's answer. In other words, someone has found what the integral of the square root of 1 plus u squared is. If you had to do it the hard way, you'd have to do an x sub, which would add on another 15 minutes to this question. So let me show you how you get the answer to the square root of 1 plus u squared. Over in Canvas, I have got this guy. So you all looking at Canvas, I hope? No? Are you looking at Canvas now? Right. See this guy at the bottom? Standard integrals. I found it on the ebook and just copied the darn thing because it was so hard to find. So here we go. When I click on this guy and I zoom it up, these are the standard integrals. Can I do it anymore? Can I do it like that? That's probably better. Yeah. Right. Do you see what we've got here is basically integrals and the answer that they're equal to. So I want to get a 1 plus u squared. So that's the one I'm picking. Now, do you see question 21 has a squared plus u squared? So that means it'll work for 4 plus u squared, 82 plus u squared. Now, since I've got 1, that means a is 1. And so the answer is going to be u over 2, the square root of a squared plus 1, which is 1 plus u squared. So every time I see a squared, I think of 1, plus a squared over 2 is 1 squared over 2, so it's a half. The natural log of a u plus the square root of u squared plus 1. Oh, there we go. Let me return. Where the heck are we? Right, stop share. So basically you find the integral, the standard integral, and this here will tell us what our answer is. So I found that guy's standard integral. And I hope I wrote him down right. He's this guy. Now, if you then return everybody back to their original, in other words, replace the u by that, you get 1/4 sine of 1/4 x all over 2 square root of 1 plus, it will end up being 16 when you're finished, 1/4 x plus a whole load of other stuff evaluated at x equals 0 to x equals 4 pi. So I'm not finishing that because it's downright ugly and it's big, but would you agree that you'd eventually be able to plug in numbers and get your answer? You could, however, do this integral but not with x equals 0 to x equals 4 pi, because that's the x limits. But you could convert them into what they would be for u. So you say, well, how do you do that? Well, if you take your u sub, and you look at the limits, and the limits were 0, well, when x is 0, u is 1/4 the sine of 0, which is 0. And when x is equal to 4 pi, then u would equal 1/4 the sine of pi would be equal to 1/4. So you could change the limits of integration from u equals 0 to u equals 1/4 and plug them into that, which is probably a little bit nicer than plugging into this converted version. So that's a little trick you can sometimes use when you've done a u sub and you're after a numerical answer. If you do a u sub, but you're after an answer with x's in it, you got to continue to the end. Okay, hopefully that is one messy question. You won't see too many like it. In fact, did I do, hope I did I do a perfect square situation yesterday? Did we do any that had a perfect square inside the square root?
I think you did a number of those.
Okay, so we can call that one done. Let's, where's actually go? Okay, let's try question 12. No, not yet. I want to do another rotate about the x-axis. Have I done, because I don't think I have, question 11. Do you recognize that? If you've not, then we're good to go. Yep. Right. This question is also rotating in a curve, this curve, about the x-axis. But because all the information is given in terms of y, we're going to use this version down here. So let's find its derivative. Multiply by the power and reduce the power by 1. 1 plus the derivative squared is 1 plus all of this squared. If you square 3, you get 9. If you square a half, you get 1 power. This is going to be 1 plus 9y squared plus 18. So what's that going to be? 9y squared plus 19. I know that's not a perfect square because there's only 2 terms. Pretty much I know that that's as good as that's going to get. So I go here and I set up the integral. It's going to be from y equals 1 to 2 pi y, the square root of this guy. Okay, I'll take it maybe a couple of lines more and then I'll call it quits. What method are we going to use to integrate that? What method will we use to integrate that? I'm not sure what the problem is because it's not a trick question.
You'd probably have to u sub, right?
Yes. And who will the u sub probably have to be?
9y squared plus 19.
Right. I wonder why there was a pause there. Is it because of what we did before that you start talking yourself out of the right answer? Yeah, you know, you're thinking 3y or something. I don't know. Maybe that's what it was. Right. If you differentiate with respect to y, and you get 18y, you do the crossover, and then you divide both sides by 18y to isolate the dy. So we now have the integral from 1 to 2 pi y square root of u times 1 over 18y du. That gets you a ninth, so I'll pull out the pi, and shouldn't really have done limits integration now. Square root of u du. Okay, can I dot that? Would you agree that's a pretty easy integral to finish? So, nowhere near as scary as the previous question. Any questions now about rotating a shape in the x-axis? Because that's the only ones we've done right now, yesterday and today. Finding surface areas of objects rotated in the x-axis. Are we good? So now we're going to have to move on to rotation about the y-axis. So you can imagine something like this. Where we have an object, curve, starts here and it finishes here. And it's being rotated. We'll call this guy here C, call this guy here D. And when you rotate this shape about the y-axis, trying my best, but okay, I've done worse. It would probably look something like this shape. Kind of, sort of, right? Just to visualize it. So we want to find the surface area of this shape here. Well, you get formulas that look just like this, but they are adapted. Oh, wait, this is great. I know that whiskey's beginning to sound like a good idea. Just saying, haven't done it. So this formula here gets altered. Now, even if you haven't seen what this new formula is, it can quite easily, you could figure out what it is by using this as a template. Couldn't it be from C to D, 2 pi g of y, the square root of 1 plus g dashed of y squared dy. Do you see all I've done is switch everybody around, right? A is a C, B is a D. 2 pi g of y instead of 2 pi f of x. 1 plus derivative, the variable is y. Does that seem reasonable that you could use this and with a little bit of tweaking figure out what that one is? Now this would be the formula that you would use when all the information uses y's. But you can also have a curve that is in the y equals f of x form, but still rotated about the y-axis. And when it does that one, you use a version of this fella. So, or if it uses x's, you use this one. So it's going to be s equals a to b, 2 pi. What do you think the y turns into?
Just X.
Correct. Square root of 1 plus, what do you think g dashed y turns into? Think reverses, think opposites of. If f dashed x turns into g dashed y, what do you think g dashed y should turn into?
F dash X.
There we go. Or I guess you could memorize all 4 formulas. So here is rotating about the y-axis when all the information is in terms of y. And here is rotating about the y-axis when all of the information is given in terms of x. So in total, as you can see here, there are 4 formulas, right? So let's find one of those guys. Question 12. Y is equal to 1/3 x to the 3 upon 2. And x is going from 0 to 12. And this time it's going to be about the y-axis. So the first thing I have to do is figure out which one of these two is going to work with this information. Well, I'm looking at it, it's got x's and the limits are x's. So shouldn't I be using the one with all the x's in it, which is this formula? So far, so good. Right. So differentiate this guy, you get 3x to the half. 1 plus the derivative squared gets you 1 plus 3x to the half squared, which gets you 1 plus 9x. Can't really do any more with that, so I'll stop and I'll now use this formula. It's going to be the integral from a to b of 2 pi x, the square root of 1 plus the derivative, which is 1 plus 9x dx. It's going to go from 0 to 12. And we have to integrate this fella. 2 pi x, the square root of 1 plus 9x. I'm even telling you it's a u sub. You tell me which u sub I should use. Two pi x, the square root of 1 plus 9x. What u sub should I use?
Nine X plus 1.
I would agree. It's actually a pretty straightforward, isn't it? The ugly thing inside the square root. Now let's see. You might not kind of see where it's going to go yet. It might look like it's not going to be of any use, but trust me, it is going to work out okay in the end. So I have, well, let's stick the 2 pi out of the way. 0 to 12 of x, the square root of u, times 1/9 du. So I now have 2/9 pi, an integral, an x, a square root of u, and a du. That normally would be bad news, but it's not. but I do have to figure out what to do with this x. I can't leave it as x. I need to turn it into something with a u. Is there anything over here that we could use to find out what x is in terms of u?
Yeah, you could
U.
just simplify it to make u minus 1 divided by 9 is equal to x.
Great. So let's do that. 2/9 pi integral of u minus 1 over 9. I'll turn the square root of u into u to the half. And then, well, we just got more fractions. I keep pulling out all the ugly numbers. And what we're left with right now is that line, right? We're darn close to this question, the hard part being over. What do you think I should do now? U minus 1 times u to the half.
Would you combine the terms?
Okay, so you get 3 halves minus e half du. Okay, so add 1 to the power, divide by the new power, add 1 to the power, divide by the new power. Make it look pretty. Okay, what should I do next?
What do you do with the pi?
Oh, nothing, just lost it. Right, what should I do next? Well, we're done close to this question being finished. Do you think we're going to leave it as is, or are we going to do something?
This is where we sub back in.
This is where we sub back in. Now we can evaluate at 0 and at 12 and expect one really ugly looking answer. But it is the answer, right? The math that we're using is pretty much the same no matter the situation, right? Rotate about the x, rotate about the y. Use a formula with nothing but x's in it, use a formula with nothing but y's in it. Of those 4 combinations, situations that can happen, the math that you end up doing are very similar, right? You end up doing the same kind of things, sometimes in x's, sometimes as y's. But there is a good overlap of skills. Let's talk about how you would start 13. Not the question, doing it, but just how you would get it into format. That would allow us to do it. So we're taking this weird curve and we're going to rotate it about the y-axis, which means it has to be one of these 2 formulas, right? You use the top formula if everything is in y's, and you use the bottom formula if all the information is in x's. Now here, we don't have a clear form of, is this x's or y's, because they're basically both jumbled together. But would you agree that the limits are y's? And so that gives me the clue that you want the top formula. But if I'm going to do the top formula, right, don't I need to take this fella and somehow rearrange it to be x equals a function of y. So I'm just going to do some algebra on this. If you subtract y to the power of 2/3 from both sides, you get that. If you take this fella and raise it to the power of its reciprocal, you now have x. So that guy there is essentially going to be your g of y. And you can now use that formula. So you see, you may have to do some algebra, depends on the question. Now, suppose it was a similar looking question. Suppose I asked you to take this shape and rotate it about the y-axis. Should I be using the formulas that has all the y's in it, or should I be using the formulas that have all the x's in it? It has to be one of these two. Why? Because it's being rotated about the y-axis, which means it has to be one of these two. Which one is it? All the y's or all the x's?
The one with x's.
Okay, which means this has to be turned into a y equals function of x, doesn't it? Right, well, the math of that would be pretty similar to this one. Subtract x to the power of a quarter from both sides. And then wouldn't y be 4 minus x to the quarter to the power of 4? And then off you'd go and do what you have to do. So setting the information up so that you can use whichever is the correct, appropriate equation can sometimes be the first thing that you need to do. Now, thankfully, in many questions, that is not the problem because they are set up the way you want to do it. This next one, where am I going? It really doesn't matter, they're all ugly. Let's do 14. I have x equals the square root of a squared take away y squared. And y is going to be from there to a over 4. And it's about the y-axis. Well, in this question here, it's pretty obvious I'm going to use the top formula. Would you agree everything's already in y's? So this fella is going to be called a squared take away y squared to the power of half. A, by the way, is just a constant, right? It's just a number, so don't treat it anything special. If you differentiate this one, you get 1/2 a squared take away y squared to the negative 1/2. But also, don't you get the derivative of what's inside with respect to y? And if you differentiate a squared minus y squared, you only get negative 2y. Why don't you get 2a squared minus 2y? Why is that wrong? Why is it just negative 2y?
A is a number, so it goes away.
Yeah. Now, if I tidy this up, I get negative y, a squared take away y squared to negative 1/2. If I 1 plus this guy squared, I get 1 plus that guy squared. Square this guy, you get plus y squared. Square this guy, you get that. And what do I have? Now I have 1 plus a squared y squared minus y to the 4. It's quite interesting and was not what I was expecting. And that's why I wasn't expecting it. Does anybody know what I lost in the thing? There. That was -1/2. So when you square it, you get -1. So what I do get is that guy. Right? -1/2 squared just makes it -1. Okay, and -1 power is basically the guy on the bottom. We have seen this at least twice now. What do you think I should be doing next?
Make the one a special version of one so you can combine them.
And when you add them together, you now get a squared on the top and a squared minus y squared on the bottom. So doesn't that 1 plus derivative squared look quite nice now compared to what it could have been, right? It's just this guy. So we can now move to here, right? So it's going to be the integral from 0 to a/4, 2 pi, the original function, a squared take away y squared, times the square root of this guy. Now we have to fight our way through some more algebra. I'll pull out the 2 pi. This can be split. The square root of a squared is a. The square root of that guy is a squared take away y squared. And then it's like magic. Oh, this cancels out that. So what you're left with is 2 pi, the integral from 0 to a/4 of a. Now, you weren't expecting such a nice answer. Well, if you integrate a constant with respect to y, you get ay. Evaluated at 0, and in this case, a/4. A times a/4, take away 0. That's a squared over 4. 2 pi times a squared over 4 is 1/2 pi a squared. We're done. And that's the end of that one. We're coming to essentially, will have to be my last question. I'm trying to think of which one I want. There are many different flavors of what could happen, and you just have to figure out how you're going to approach it. So we do have rotation about the y-axis, and we have rotation about the x-axis, right? So there's 1, 2, 3, 4. So let's just talk about setting up for the next few questions. I'm not going to do them, but just set them up. So we have xy is 3y squared take away 1. The y values are going to go from 1 to 4, and it's going to be rotated about the x-axis. So the way I would do this is, that's the crucial piece of information to start with. If you rotate about the x-axis, doesn't it mean it's one of these two? Agreed? Now, I use the top one if the information is all in x's, and I use the bottom one if the information is all in y's. This is jumbled up, so it's hard to tell what's going on, but would you agree this is y's? What that tells me is this is the right formula. So when you're setting up, choose the correct formula. So I'll go over that process I just did. You rotate about the x-axis. That means it's one of these two. You look at the information, and in particular, this information here. And this tells me that it's going to be the one with the y's. So I'm going to be doing the integral from 1 to 4, 2 pi y, the square root of 1 plus a derivative squared dy. Now, sometimes, and this is one of those sometimes, the information that you're given here isn't quite written in the way you want it. Don't you want x equals g of y here, right? X equals function of y. So I'll just look at this guy and I'll say, well, okay, if you divide both sides by y, there you go. Can you see the thing is now set up? And then you do what you need to do. That's all I want to do for that question. See if we can. Question 16 is basically good to go. But let's write it down and see what we have. We have this curve from y equals 0 to 1, and it's going to be about the y-axis. Now, since it's being rotated about the y-axis, doesn't it make it one of these two? Right. This is the two that you use when you're rotating about the y-axis. Now, look at the information the way it's given. That's a 6, by the way. Are we going to use the one with all the x's in it, or am I going to use the one with all the y's in it? Which formula? Top or bottom?
The top,
Correct. Why? What made you decide that?
because it has the y terms in it.
Yeah. And so in this case, it would be the integral from 0 to 1, 2 pi. That guy is basically g of y in this theory. So derivative, and off you go. Send to that one. '17 is obvious. This is 18. Y equals 1 over x. X goes between 1 and 5. And this time is to be rotated about the x-axis. Right? Since it's rotated about the x-axis, we use one of these two. If the information contains x's, I use the top one. If the information about the curve contains y's, I use the bottom one. Would you agree this contains information with x's? That means top one. So it would be the integral from 1 to 5, 2 pi f of x, square root, whatever you get, dx. So one of the things you're going to do when you see the homework and later on the test question is, you've got 4 formulas, right? But only one of them is the right formula in each circumstance. And so you need to be able to look at things and say, yeah, rotate about the x, it's one of these two. Which one? That one. Maybe the next question is rotate about the y. Which one is going to be this one? Right? There are 4 choices, but only one of them is going to be relevant to the question in front of you. Let's zoom up here for a second. Right, let's try for the last few moments, since I'm running short of room. Look at the bottom, working our way up. In this question here is the function, and here is the guy being rotated about the x-axis. Actually, let me just hold on to that one. I'll do that one as the first one tomorrow. Right, let's look at this one. Y is a function of x. X is 0 to 6, rotating about the x-axis. That would be rotate about the x-axis, the top formula, right? The one with the x's in it. And this one here God, look how ugly the answer is. Since you're rotating about the x-axis and everything is in x's, wouldn't that one be the top formula in rotating about the x's? In this one, you are going to be doing a y-axis, and can you see that all the information is in terms of y's? So if you were doing the y-axis one and you were doing all the ones with y's, it would have been the top one. And in this case, that's the horrible integral, but you don't need to do any algebra. You just plug that into your calculator and you get that horrible decimal. And this one, you plug it into your calculator and you get that one. And then this one, you plug into your calculator and get that one. And we are going to have to call this a day. So last name before you go, and bye-bye.
I hope you feel better.
Oh, I hope so too. And if I don't, David, I'm just going to give it to you so I can get rid of it. No, you're not keen on that? Okay, I don't blame you. Okay, any questions while we're hanging about?
I have a question on number 15.
Okay, I got 15 in front of me. We just set that one up, so I'm wondering what your question's going to be. Here we go.
I tried plugging it into WebAssign, and it doesn't like the answer, and I don't know why.
They keep changing. I don't know yet, so I'll try and take it a little bit further and see what we get. So we have 3y, y to the -1, because I want to differentiate. That would probably be the way to do it, right? So its derivative is 3, 2 negatives make a plus, y to the -2, which I'm going to call 3 plus 1 over y squared.
Mhm.
And I'm going to do 1 plus its derivative squared. So it's 1 plus that guy squared. Nothing very interesting happening right now. 9, 6 over y squared plus y to the 4. And I get this guy. And I'd be amazed if that was if that was a perfect square, which is not, which is interesting. So it's going to be the integral from 1 to 4 of 2 pi, the original function, which is 3y times 1 over y, followed by the square root of 10 plus 6 over y squared plus 1 over y to the 4. I can't see anything that comes out to unless I screwed up. That's not going to work with a U-sub. Question.
So there you have 2 pi f of y, and then the square root of 1 plus derivative squared.
Yeah, essentially. dy. Did you get something like that?
I have almost that. Did I
Right,
not choose the right formula?
I don't know.
On the
This is 2 pi g of y, and this is 1 plus g dashed of y all squared. All right. Are we good? So making sure that's g of y. G of y is 3 take away 1 over y, which is fine. That's what it is. So what here is different from what you got? Because at this point here, you just put it into your calculator and you get 1.2345, whatever it is. So you got this piece, right? Is it this bit that doesn't match what you got?
Oh, I think so. When I was following along when you're doing the question, you have 2 pi y at the start, and so I left the y in there, I didn't do like f of y.
Ah, okay. So it's just the wrong formula then.
Yeah, okay.
Right, there are 4 formula right there, so yeah, choosing the correct one is a big decision. If you don't do that right, it just ain't going to work, essentially.
And then the
Okay.
February.
Right, any other questions? Because I'm going to be leaving in a few moments for my next class.
I do have a question.
What you got?
So on number 9, when you were changing the x values to u values, to solve it before, to solve the u substitution,
Mm-hmm.
so you got x, when x equals 4 pi, y equals 1/4. But wouldn't it be?
Yeah. Let me check, because it could be me screwing up here. The u sub that we used here was what? It was 1/4 the sine of 1/4 x, wasn't it?
Yes.
So we plugged in 0, we got, when x was 0, we got, well, basically the sine of nothing, no, just nothing. And then when we plug in, is it 4 pi? What did we get then? We should have got 1/4 of the sine of pi. Oh, the sine of pi is 0. Nah. Well, that would be an easy question, because isn't 0 give me 0? So what the heck was going on there? Oh, that's probably this. Should have probably been 2 pi. So I wrote the question down wrong. And that would make a big difference, because you'd get a half pi, and a half pi would get you a quarter. So if you make that 2 pi and not 4 pi, everything matches up. So make that 2 pi and not 4 pi, and it works.
But isn't the sine of 2 pi also
But
zero?
it's a quarter of 2 pi. So it's now a half pi.
Oh, gotcha. Thank you.
Okay, we are out of here. I'll see you tomorrow or during the office, or if you have something before then.
Thank you.
Okay, bye-bye, guys.